In this video, I'll show you how to make this double-sided chess piece. Once that's complete, I'll show you how to create all the tooling that you need to cut it as a two-sided project on your CNC machine. So I've gone ahead and opened up a fresh new session of Aspire and loaded in the file from my tutorials folder called chesspiece-king-outlines.crv3d file. As soon as I do that, I'm brought to my 2D view, but for this job, I can do everything I need to do in the 3D view. So let's just go ahead and flip over to that. You'll see that I have those same two vectors showing up on my modeling plane in my 3D view. I have an open vector here that defines the side of the body of my chess piece. And then I have a closed vector that's going to be used to create the cross for the top. These are really simple vectors that came from tracing a bitmap that I drew on a piece of paper. I can also go ahead and hold down my right mouse button and I can twiddle around my view if I would like to. If I happen to get lost and I can't quite get it back straight like a bird's eye view, I can go ahead and click on the top face of my view control to bring that back into position. Now the first thing I want to do is create all the components I need to create one half of my chess piece. The first thing we're going to do is select this open vector and go over to our create a shape by spinning or turning a vector. If we click on that, we can go ahead and use the turn. And what that's going to do is actually turn this vector over the center line of my job. I'm going to make sure that I don't have any scale to exact height turned on. I'm going to merge this component in, and I'm going to call this chess piece body. And then I can go ahead and click apply, and you'll see that in my 3D view, I've turned that vector over the center line, and I have this nice half of a chess piece. That looks really good. Let's go ahead and look back down on that again and close this down. The next thing we're going to want to do is actually create the cross for this. So with that vector selected, I'm going to go over here to my modeling tools and create a flat shape. As soon as I do that in my 3D view, you'll see I've got some control handles visible, and I also have this icon right here, which what that will do is if I go ahead and click on my left mouse button and hold it down, I can go ahead and drag it up, and you'll see that I'm starting to create a flat plane. I can let go of that and I can rotate around my model and make sure that it's not too thick. In this case, it's a bit too thick. So I'll just go ahead and again hold down my left mouse button on top of that icon, and I can go ahead and pull that down until I'm happy with the height of it. And that looks okay right there. The next thing I want to do is to make sure that I set the proper combine mode for this cross or for this component so that it interacts with the body of this chess piece properly. Right now it's being added on. If I go ahead and bring up my floating properties dialog by clicking on this icon right there, then you'll see that it's set to add. But what I'd like to do is set it to merge. As soon as I click that, that component will be merged in with this body of my chess piece. That's exactly what I was hoping for. So let's close this down. Look back down on the top of our component again and press escape to get out of our create flat shape tool, and then unselect everything by just clicking into the white space. Now that's perfect. That's exactly what I was looking for. Let's go ahead now and organize our file a little bit. Let's go up to our levels, and we're going to rename level 1 models. So right click on that, go down to rename level, and we'll call it models. Okay. And you'll see that when we created the chess piece body, we called it chess piece body, but when we created the cross, we didn't give it a name. So let's just go ahead and select that, right click on that, and we'll go down to rename that, and we'll call this cross. Now looking at this right quickly, you'll see that the cross has been merged into the chess piece body, and you can tell by the little icon here at the front of the names. And also that the models level is added to the project. Let's just go ahead and click outside of that now. You can also go and view your component tree by using the Components tab over here in your Design tab. And you'll see right there that this is a reflection of what you see up here. So there's two different ways to get to that. So now that we have the two parts that we need to create one half of our chess piece, we need to go ahead and move forward with creating the other side. Currently right now, this is only a single-sided job. So we're going to need to change the job type to be a double-sided job and check to make sure that all of our job settings are correct. So let's go up to our File Operations section of our Design tab and look at our job setup. Currently right now, like I mentioned, it's a single-sided job, so we're going to go ahead and turn this into a double-sided job. Our job size should stay the same, except for we're going to want to make sure that the thickness of our material is safe and appropriate for a double-sided project. And right now, 1.75 inches seems about right, but we'll check that in a minute. When we go ahead and set up our 0 position, we're going to want to make sure that on the first side, we go ahead and 0 off our material surface. But on the second side, we want to make sure that we 0 off the same side. So when we click that, you'll notice that the icon has switched to indicate that we are going to 0 the second side off of our machine bed. So the first side will be off our material surface, and the second side will be off our machine bed. Our data will be set to the same, but now we need to choose our flip direction of this project. And for this one, we're going to flip from left to right, opposed to bottom to top. And we're going to keep the very high modeling resolution, and we can just go ahead and click OK. Okay, now that it's a two-sided job, you'll notice that there are some new options here showing up in our interface. Across the top, we can go ahead and toggle on and off our double-sided view. And this double-sided view not only affects the 3D view and the 2D view, but will also affect your Toolpaths preview, so you can preview both sides of your job when you're checking your toolpaths. We can also go ahead and flip from front to back by using this button here. And the arrow indicates the option that we've chosen in our job setup on which way we're going to flip. So if you forget, just look right there. Also, you'll see that in our view control, that the top now has a black outline around it. That's so that if you happen to get a little bit lost on what side of the job you're working on, you can tell that you're on the bottom, but really you'll be working on the top side of your job. So we can just go ahead and double click on our bottom and bring us back to the top again. So the next thing we want to make sure is that our chest piece, when it's doubled up, when we have a front and a back, it will fit with inside of our material block. So if we go ahead and select the chest piece body, we can hover over top of this icon here at the end, which is the scale, the component. And you'll see that it's set to 0.745 inches. So if we double that, that will easily fit with inside of our 1.75 inch thickness material block. So let's go ahead now and select those two components that we have made by holding down our Shift key. We can right click on those, and we can say copy to the other side. And because we have our double-sided preview turned on, if we go ahead and rotate to the back side by holding down our right mouse button, you'll see that we can see both sides of our chest piece. They line up perfectly. Now we can also go ahead and hide our 2D vectors, and we can hide our modeling plane so we get a much clearer idea of what's going on. And those line up exactly right like they should. Okay, let's just go ahead and turn back on our vectors and our modeling plane. And for now, just to make things a little bit easier, we're going to go ahead and turn off our two-sided view. So now that we have both of the sides set up, we're going to need to think about how we're going to cut this. So we need to consider two new things. One is, how are we going to hold this part into our material block once we cut it out? And also, we need to come up with an accurate way to flip the part over so that the back and the front will line up perfectly. So first of all, let's look at securing this into our material block once we have the front and the back cut. To do that, we're going to need to add in some tabs. And because I've already gone ahead and downloaded all of my free clip art that comes along with the Spire, I have a group called 3D tabs, a group of clip art. And in here, I've got all kinds of different 3D tabs that I can choose from. In this case, I'm going to go ahead and choose the rectangular tab. So just double click on that. And you'll see it'll show up right in the center of our job. Let's just go ahead and move that out of the way for a second. Now I'm going to need to use probably 4 of these tabs, one on each side of the cross and 2 on the bottom of this to make sure it doesn't fall out. So first of all, I'm going to rotate this around 90 degrees. And to do that, I can just simply go ahead and click on the rotation handle and type in 90 and press enter. I could have also gone ahead and pressed 9 on my keyboard twice, and that would have rotated around in 45-degree increments. But this is perfect. And then what I want to do is just scale this down so it's about the right size that I need it to be, probably somewhere around there. I'm just going to move that into place, and that tab's going to go somewhere around there. It could be just a little bit smaller maybe. Just size that down a little bit smaller. There we are. And we'll put that where it belongs, somewhere around there. The next thing you want to do is to make sure that it is merging properly in with our cross. So if we go ahead and turn it on its edge, it looks like it's merging in perfectly fine. So that looks great. It's a little too thick, so let's just go ahead and change the scale of this down a bit. So we're just going to left click and drag down until it fits in there nicely. And I think that if that's doubled up on the front and the back, I think that'll be the perfect thickness tab to hold that in place. Let's go ahead and look back on the top of our job again and then click out here. Now all we're going to want to do is just go ahead and copy this across. So we'll select that, and with our Alt held down and our Control key to copy, so Alt will keep it in its locked into its vertical positioning, and the Control will make a copy. I can just make a copy over here, really easy. And then like I said, we're going to add 2 in the bottom. So let's just go ahead and hold down my Control key, and I'll copy it down here. We'll just position it down here. We can hold down our wheel on our mouse, and I can just move it up a little bit. Again, we're going to need to rotate this around again, so let's just go ahead and click on that, and we'll change this to 0, and press Enter. And I'll turn it back around again, and then I can put it up into place where I want it to be, right about there. Now I want to copy it across so it's exactly in the right place on the other side as it is on this side. And to do that, if I hold down my Control key and my Shift key, that'll make sure I make a copy of it. That's the Control. Holding down the Shift key will make sure I can copy it across the plane. And if I press H on my keyboard, it'll copy it across my job. And there we have it. That's great. Let's go ahead and look back down on top of our job again. As always, it's really important that we keep our job organized. So let's go up to our levels menu here for a second and drop this down, and we'll see our component tree. Now when we brought in those tabs, you notice that they all fell on top of our model's level. Now that's fine, but because we want to utilize our levels in a little bit, then we're going to want to move those onto their own level. So let's just go ahead and right click, and we're going to say insert a new level, and we'll rename that tabs. And we're going to want to make sure that this is a merged level. So we'll right click on that, and we'll change the combine mode to merge. And then we simply need to go ahead and hold down our Control key and select all the components that we'd like to move onto that level. That's all the tabs. And we're just going to drag those up and pop those in there. Now nothing has changed in our 3D view, but it's a little bit more organized so that we can use these levels to our advantage a little later on. Okay, so now we have the tabs on the front side, but we're going to need to copy those over to the back side of our job. Now with our two-sided view turned off, we won't be able to see the result of that copy, but be reassured that they will be copied over to the other side even though we can't see it. So let's go ahead and select those by holding down our Shift key, right click, and we're going to say copy to the other side. And there we go. They're copied over to the other side for us. The next thing we're going to need to think about is how we're going to ensure that the front and the back line up correctly when we flip over our part. Now, if this is your first time ever doing a two-sided job, I highly recommend that you go ahead and watch the video called Introduction to Two-Sided Machining, and that'll be in the related videos. That'll give you all the ins and outs of how to do this. So what we're going to need to do is cut 3 asymmetrical dowel holes in the top of our part. And once we're done machining all of the tool paths for the top of our job, we'll remove it from our machine. We'll cut the flip version of those dowel holes right into our spoil board. We'll push some dowels into that. And then when we flip our material over and push it down on those dowels, we're reassured that everything is going to line up correctly. So let's go ahead and create those dowel holes on this side of our job. So to do that, we'll go over to our Design tab, and we're going to create some circles. And the diameter of our dowels that we have are about 0.33 of an inch. So all I need to do now is just go into my 3D view, and I can click anywhere as I'd like to and drop one of those in there. You'll note that the entry field for this is the radius, not the diameter. Put one here, we'll put one down there. And that's perfect. So we can just go ahead and close that down. Now again, what we're going to want to do is select those. right click, and we're going to want to copy those to the other side. And when that happens, our software will automatically flip them left to right so that when we flip our part over, they'll line up exactly right. Okay, we can illustrate that pretty easily by just flipping to the back and to the front, into the back, into the front, and you'll see that those circles slip back and forth left to right. So the last thing we're going to want to do before we actually go ahead and create some tooling is to add in what we call a limit plane. So right now, we are limiting our toolpath depth by the modeling plane. So as the tool rolls off the edge of our model, then it will stop at our modeling plane, which normally is okay. But in this case, what we want to do is we actually want it to cut just a little bit deeper. That way it will eliminate any of the radius tool marks along the edge of our part. Because when we go ahead and cut from the other side, we're going to stop at the modeling plane and it will clean it up for us. So to look at that, what we can do is just slide this over to the left-hand side. We're going to be using a 1/16 inch ball nose end mill to cut this. So as the tool comes down, currently right now it'll stop at the bottom, and that will leave a little bit of a cusp. Well, we can get rid of that by forcing the tool to go just a little bit deeper. So to fix that, we're going to go ahead and add in a zero plane. So if we go ahead and hold down our shift key while clicking on the create a flat shape component, you'll see that now we have a zero plane in there. And the zero plane is a flat plane without any base or shape height to it at all. So we're going to select that, and we're actually going to click on the base height button here. And we're going to put in minus 0.0625 and then press enter. And you'll see that our modeling plane, or that zero plane we just created, now has moved down just a little bit so that we're going to force our tool to cut past the center point of our chess piece. So let's go ahead now and look back at the top of this again. And now we have pretty much everything that we need to go ahead and create some tooling. Okay, let's go ahead and jump over to our Toolpaths tab. And the first thing, as always, we're going to want to go ahead and check our material setup. You'll see that our material thickness is 1.75 inches. This gives us an opportunity now to go ahead and check our material thickness and make sure that it is correct. And this, in my case, it is. Our XY datum will be set to the bottom left-hand corner. For this side, we're going to be zeroing off our material surface. And what we would like to do is actually position our model in the middle of our material. So let's put that down in the middle here, where it belongs. That way there's equal amount of material at the top and equal at the bottom, and this should be right in the center of our material block. And our rapid Z-gaps and our home start position are safe and appropriate for our machine. Let's just go ahead and click OK. Now the first thing we're going to do is we are going to go ahead and cut our dowel holes. So we're going to select these vectors, these circle vectors, holding down our shift key. And we'll go over and we'll create a pocket toolpath. Our start depth will be at 0, and our cut depth will be at 0.7 of an inch. We're going to use a 1/4 inch end mill, so I can remove this 1/8 out of there for now. We're going to use offset tooling, and we're just going to call this dowel holes. And we can calculate that. Okay, and we'll preview that visible toolpath, and that's exactly what I hope to see. So that's great. Let's look back down on top of that again, close down our toolpath preview. Now the next two toolpaths we're going to make are pretty much our standard toolpaths for cutting a 3D component. We're going to make a roughing pass and a finishing pass. So let's go ahead and choose the roughing pass. And we're going to deselect those vectors. We don't need those selected right now. So for our roughing pass, we're going to go ahead and select a 1/4 inch end mill. So just going to make sure that we have our proper material selected here, and also the machine that I intend on using, which is my desktop machine. I can just go ahead and check select. Now, the next thing I want to do is to limit my machining boundary, okay? And to do that, I have some different options here. I could use the model boundary, the material boundary, a selected vector. But for this particular case, I want to use a selected level. If I had actually used a vector around my chess piece and these tabs, what would happen is actually cut out my part, and I don't want it to fall out. So I need to make sure that I don't cut off these tabs or cut past these tabs. And to do that, I can use my selected level. And I'm going to choose my level models. That's because, remember when we did a little bit of file organization here, we moved those two models onto the models level here. And that's going to help me to isolate my tooling to that, just to those two pieces. We're going to use a boundary offset of 0.125. We're going to use a machining allowance of 0.02. That'll leave a little bit of material behind, so we can go back with our finishing pass and remove that. We can use Z-level roughing, and we're just going to call this roughing, and we can calculate that. Preview that visible toolpath. And that's exactly what I was hoping for. That looks really good. So let's close that down, look back down top of my model again. Now let's go ahead and create the finishing pass. To do that, we're going to go ahead and remove the 1/8 inch ball nose I have there, and we're going to select the 1/16. Again, making sure I have the right material and the right machine selected. Select that. We're again going to use the selected level. So we're going to make sure that we choose models from that. We're going to give that a slight boundary offset of 0.0625. Okay, and we can use a raster toolpath for this time around. We're going to call this a 3D finishing, and we can go ahead and calculate that. And we'll preview that visible toolpath. Now at this point, we can see the cusping at the edge of our actual model here. But remember, we're cutting past the actual halfway point of our model. So when we go ahead and clean it from the other side, we shouldn't see any cusping at all. It should be a nice clean cut. That's all we need for the top side of our project. So let's close this down. Let's go ahead and flip to the back side. Look back down on top of our project. And now we're going to check our material setup again. So again, our material thickness is exactly what it was. It shouldn't have changed any. Our XY datum is the bottom left-hand corner. And because when we were setting up our job, we said that we wanted to actually zero off the same side, this time around we'll be zeroing off our machine bed. We're going to make sure that our model is still in the center, which it is, and the rapid Z gaps and home start position are safe and appropriate for this side of our project. And we can just go ahead and click OK. Now this time around, we're going to select these 3 dowel holes. We're going to calculate a pocket toolpath again. We'll go in that 0.7 of an inch. We're going to use that 1/4 inch end mill. Offset tooling. But in this case, we're going to call this dowel holes spoil board. And that's important because we're going to cut the first side, all the tool paths. We're going to remove it from our machine. Then we're going to go ahead and zero our tool off our machine bed. And we are going to cut these dowel holes right into our spoil board. Place our dowels into these holes. Flip our material over and push it down on top of the dowels. And then continue to cut the tool paths for the back side of this project. So we can calculate that. And we can preview that visible tool path. That's great. Go ahead and close this down. Look back down on top of our job again. Let's do our roughing pass. Let's just go ahead and make sure we unselect everything. So we're going to use that 1/4 inch end mill. We're going to use a selected level again. We'll use level 1. All this is exactly the same. We'll just go ahead and delete that. And we can calculate that. We'll preview our visible tool path. Looks exactly right. No problem there. Let's close this down. Let's go ahead and cut our 3D finishing tool path. We'll remove that tool out of there. We're going to choose that 1/16 again that we had a minute ago. Okay, that's great. We're going to make sure we use the selected level again. We'll do a little bit of boundary offset. Raster tool path. We'll call this finish. And then we'll calculate that. And then we can preview that visible tool path. What you're probably going to notice straight away is that I didn't do any file organization for this side. So these tabs end up being on the same level as my models do. So what we're going to do is we're going to go up to our levels manager here. We're going to go ahead and make sure that we set this all up like we should. Models, right click, insert a new level. We're going to grab all those tabs. We'll move those up into that level. Rename this tabs. And we're going to make sure that we merge this in just like we did on the other side. And now what we can do is we can go ahead and close, we can reset our preview. We can close this down. We can recalculate these tool paths. Then we can preview our visible tool paths. And we'll see now that on our back side, we've gone ahead and made sure that we didn't overcut those tabs. And that's exactly right. Let's go ahead and 3D preview both our toolpaths or sets of toolpaths on our front and our back of our job at exactly the same time. Let's turn on our double-sided view. We're going to preview toolpaths for all the sides. Now, if we see anything wrong with this particular preview, then it's time to go back and make any changes that we need to. And that looks exactly right. We got a nice sharp edge around the edge of our chest piece. Those tabs are being held in place, so our part shouldn't move. And everything looks really good. So now all we need to do is go ahead and save those toolpaths off and run them on my CNC machine.